Hi friends, welcome to video 2.5. So listen, you can probably hear my voice is pretty much shot. I'm not feeling too great today. So a couple things. First of all, this video is optional. You have homework 2.5, it's a problem set. So if you found your way to this video thinking like it's required, no, this is a totally optional video. The point of this, right, is to no nonsense. Well, I mean, always a little bit of nonsense. This is me that we're talking about. But it's just going to be me doing a little bit of extra problem solving with you for anybody who feels like they need a little bit more practice, a little bit more guidance, and a little bit more like just seeing some examples. So if you feel like you're in that camp, or if you just want to watch this video and like hear me talk funny, be my guest. I'm also doing this in one take. So like if I say something weird, you can laugh a little bit, but like just don't laugh too much because then I'll cry. Yeah, but you do not need to watch this video. You can watch some of it. You can watch all of it. You can watch none of it. However much you feel like you need. Yeah, just make sure that you do your problem set and you'll be good. So for each of these inequalities below, again, now we're in multi-steps. So we've got more than one or two moves standing between us and our goal of getting our variable by itself. So first thing we want to do is solve. Next thing we want to do is graph on the number line, and then finally give ourselves our set builder and interval notation. I'm going to keep going through these problems. I would encourage you to stop, give yourself maybe a 2 or 3 minute timer for each problem before I start working on it. And then once you've gotten through maybe all of it, maybe some of it, then come back and check your work against mine. Cool. So here's your first one. 8 is less than 3, parentheses, m over 3 minus 1. Now's your chance to pause. So 8 is less than this thing. Well, I'm trying, again, my goal is to get m by itself. So notice here, I could distribute, but I could also just think, well, the thing connected to the m, I could just get rid of this 3 now. So you could divide, but notice 8 divided by 3 is going to be weird. So I'm actually going to choose to distribute. So I've got 8 here is less than 3 times m over 3. So I have to times 3 and divide by 3. That's like kind of doing 3 times 1/3. That's just 1m. 3 times negative 1 is negative 3. So I've got 8 is less than m minus 3. To get m by itself, we'll add 3 to both sides. 8 plus 3 is 11, less than m. So here is our first inequality solved. On my number line, we're going to pretend that that's a nice line. 3, 4, 5, 6, 7, doesn't matter how many. So again, my advice to you, make your life easier, not more challenging. Think smarter, not harder. Right? Don't overlabel your number line. I'll give myself my 11, and then I'll count by 1s. So maybe I'll say, I don't need to count by 2s on my tick marks, but I'll say like 12 is there, 10 is there. If I wanted, I could put them right next to each other. It doesn't matter. Give myself some ellipses to indicate that I keep going. I'll label my number line with my variable m. And then here, 11 is not included in the solution set. It's a less than symbol. It gets an open circle. M here, notice, is on the bigger side of the inequality. So m needs to be bigger than 11. I'm going to the right. For my set builder notation, again, always starts with my squiggle. And then I say m, such that, what criteria do I need to meet? I'll say m is greater than 11. I could also just say the 11 is less than m based on my solved inequality. And then finally, my interval notation. Well, on the left, I start at 11. I go off to infinity on the right. Infinity is never included. It gets a parentheses. 11 has an open circle around it. It gets a parentheses. Very nice. Here's our next one. 3 parentheses 8g minus 2 is greater than 12 parentheses 2g plus 1. If you want to pause, here's your chance. Okay, so first thing I notice, I've got dirty, stinky parentheses. I don't like them. I want to get rid of them. They make me sad. So does being sick. But like in this case, they make me more sad. 3 times 8g, well, 3 times 8 is 24. 3 times negative 2 is negative 6. Greater than 12 times 2 is also 24g. Alarm bell should be going off for you, plus 12. Notice here the issue is that I have g's on both sides. So I probably want to subtract 24g from one side. But if I do it to one side, I've got to do it to the other. Notice here, on both sides, minusing 24g from 24g will have them go away. So I'm left with negative 6 is greater than 12. What do we think? True, false? Well, negative 6 is not greater than 12. So I can't make this true. This is a fundamentally false statement. So this inequality can never be true. It has no solution. Cool. Again, my graph of a no solution, you remind me, what does it look like? 5, 4, 3, 2, liftoff. Well, if there's no solution, I can't put anything on the number line. So I'll just label it with a G, but nothing else I'm going to fill in. If you want to, you can give yourself some tick marks. But again, think smarter, not harder. Make strategic choices. Don't bother wasting the time. From here, my set builder notation, again, there's no funky way to write it. I could write it like this, or, so one of the two, you might not put both. You can do your squiggles, but there's nothing inside. And then I usually say there's no interval, so I'll write an A. Cool. Next up, a little bit more complicated, but same idea. 3 parentheses 5p minus 4 minus 2 is greater than or equal to 8 parentheses 3p plus 2 minus 3p. If you want to pause, go ahead. All right, so first thing I don't like, dirty stinky parentheses. Let's distribute. So on the left side, 3 times 5p is 15p. 3 times negative 4 is negative 12. Carry down my minus 2. Greater than or equal to 8 times 3p, well, that's 24p. 8 times 2 is 16. And then I've got negative 3p. So on the left side, I've got negative 12 and negative 2. So I can put those together to get negative 14. Greater than or equal to, on the right side, I've got 24p minus 3p. That's 21p plus 16. Now I want to get all of my p's over to one side, so maybe I'll move them to the left this time. Minus 21p. Minus 21p. It doesn't really matter which side I choose. I could have subtracted the 15p. 15 minus 21 is negative 6. So I've got negative 6p minus 14 is greater than or equal to 16. I'll add 14 to both sides because I'm trying to get p by itself. Our 14s go away. Negative 6p is greater than or equal to 30. And then I'll divide both sides by negative 6. Negative 6 divided by negative 6 goes away. And p is greater than or equal to negative 5. Or is it? What did I do? Or in this case, really, what didn't I do? 5, 4, 3, 2, 1. Well, I just divided by a negative number. And when I divide by a negative number, what happens? I do a backflip. In person, I'm getting up and doing a backflip right now. But on my page, I'm taking my less than or greater than or equal to, changing it to a less than or equal to. So p is less than or equal to negative 5 is my solved inequality. From here, I want to graph it. So on my number line, tracking values of p. So the most important thing that I include on that number line is a negative 5. Maybe off to the right, I've got negative 4. Off to the left, I've got negative 6. Keep going. Negative 5 in this case, it's always going to get circled. Notice I have an or equal to, so that circle gets filled in. So I've got negative 5. And now p needs to be less than or equal to negative 5, so the left side of my number line is shading in. I need to be smaller. Cool. Set builder and interval notation. For my set builder notation, I want all values of p such that what criteria needs to be met? Well, p just needs to be less than or equal to negative 5. And then for my interval notation, reading from left to right, all the way on the left, right, I keep going off to the left, so I'm at negative infinity. And all the way on the right, I end my number line at negative 5. That's where I stopped shading in. Negative infinity, never included, always a parentheses. If you don't have that committed to memory by now, you might want to. Negative 5 is included. It has a closed circle. It's going to get a bracket. Very good. Next up, 1 minus 2u over 3 plus 1 is greater than 2 parentheses u minus 2. So before you pause, what's something about this that you maybe don't like? Well, I've got a fraction. So there are a couple of different options that you could use here. I'd say there's probably an easier choice to make first, but no wrong way to solve this. Take some time, play around with it, see what you get. And if you don't want to pause, let's do it now. So for me, if I see a fraction, an option is always to multiply by the least common denominator. So the only thing I need to multiply by here is 3. I actually think in this case it's a little bit wiser to wait to do that multiplication. So what I'm going to do, and if you do it a different way, that's totally fine. I'm going to take my distributive property and simplify the right side. So I've got greater than 2u minus 4. From here, let me minus 1 from both sides. You'll see why I'm doing this in a minute. So now I have 1 minus 2u over 3. Those 1's cancel each other out. Is greater than 2u. Negative 4 minus 1 is negative 5. And from here, now I'm going to choose to multiply by 3. The reason why I'm doing it now is just because now that that right side is fully simplified, well, on the left side, I know that times 3 and divide by 3 are going to go away. So I've got the 1 minus 2u. And now I have my greater than symbol. Well, this 3 is going to distribute, right? I need to multiply the entire right side. So this is going to become 6u minus 15. The idea is, like, if I did it above, like if I did it over here with my orange arrow, or if I did it up here, well, doing it up here might be weird because then I'm not sure what to do before I distribute. Doing it in that second line might be weird because I might forget to do it to this plus 1. So by holding off until doing it now, right, I'm making a kind of strategic choice. But if you remember that when you multiply something, you need to multiply every term by that thing, that's totally cool too. So from here, either way, I've got 1 minus 2u is greater than 6u minus 15. From here, the issue is that all of my u's are on different sides of the equal sign. So I might add 2u to both sides here. Maybe I'll move them to the left this time. I'm left with 1 is greater than 8u minus 15. I want to get the u by itself. Easiest thing to get rid of first, reverse order of operations. SADMAP. Let's do the plus 15 first. So I've got 1 plus 15, which is 16. That's greater than 8u. And now I need to divide both sides by 8 to get this u by itself. 16 divided by 8 is 2. So 2 is less than u is my solved inequality. To graph it on my number line, I'm going to give myself some tick marks. Again, we're going to pretend they're evenly spaced. The most important number to live on that number line is the 2. Maybe I'll count 1 off in each direction, give myself some ellipses. Values of u are what I'm keeping track of. I'll label my number line. 2 is getting circled. Is that circle getting filled in? Well, I don't see an or equal to, so it's going to stay open. And now again, don't fall into the trap just because I see a greater than sign. The u is on the smaller side of the inequality, so u needs to be smaller than 2. So I'm going to shade in the left side of my number line. Cool. Set builder and interval. My Smash Bros. Set builder, well, I want the set of all values of u such that I could say u is less than 2. I'll just take the solved inequality here. 2 is less than u. Or 2 is greater than u, sorry. There you go. And then interval notation. Well, on my number line here, all the way on the left, right, I go all the way off, so I'm at negative infinity. End on the right at 2. Negative infinity always gets a parentheses, not included. 2 has an open circle. It gets a parentheses. Fantastic. I think we've got 2 more to do. Let's take this guy. 5x over 4 is less than or equal to 7/6 minus x over 2. If you want to pause, now's your chance. Okay. So notice here I've got a bunch of fractions. Think back to class 1.2, all the way back in unit 1. I know it's been a while. You can do it. I believe in you. So if I have a bunch of fractions that I want to get rid of, one choice that I can make to undo all of those denominators is to, well, it's division, so I need to multiply. I can multiply everything by the least common denominator. Here between 4, 6, and 2, what's the least common denominator? Well, the smallest number that all of them multiply to is 12. So over here, right, I'm going to do 12 times 5x over 4 is less than or equal to 12 times 7/6 minus 12 times x over 2. If you want to take our shortcut, go ahead. But because it's been a while since we've done this, Remember, I can think of this kind of like a fraction. Then I can do some fraction multiplication. Well, I have 12 over 1 times 5x over 4. If I'm multiplying those, before I multiply across, I should cross simplify. 12 and 4, 4 goes into 12 3 times. 12 and 6, 12 goes into 6 twice, or 6 goes into 12 twice, I should say. And 12 and 2, 2 goes into 12 6 times. Now I'll do my multiplication. I have 3 times 5x in the first slot, which is 15x, which is less than or equal to 2 times 7, which is 14, minus, I have 6 times x. Well, that's 6x. Cool. So now I need to get all my variables over to the same side. Maybe I'll add 6x, add 6x. On the right side, they undo each other. I've got 15 plus 6, which is 21. X is less than or equal to 14. Divide both sides by positive 21 to get x by itself. 21 divided by 21 is 1, so I've just got x is less than or equal to 14 over 21. But of course, 14 over 21 is not fully simplified. Both of those are divisible by 7, so I can reduce this to 2 over 3. Cool. Let's graph it. So I'm tracking values of x. I've got my tick marks. I'll label with my x. Most important thing that I need here is 2/3. Maybe I'll count 1/3 up, which is 3/3, but that's really 1. 1/3 down is 1/3. Give myself my ellipses. So 2/3 is getting a circle. Is my circle going to be filled in or left empty? Well, it is an or equal to, so it's included. It's getting filled in. X needs to be smaller than or equal to that 2/3. Fantastic. Or Smash Bros. Well, I want the set of all values of x such that x is less than or equal to 2/3. And then for my interval notation, looking at my number line, on the left, it starts at negative infinity, ends on the right at 2/3. Negative infinity is never included. It gets a parentheses. 2/3 has a closed circle. It gets a bracket. Beautiful. And one last one for the road. 1 minus k over 2 minus 2 over 5 is greater than or equal to 2k minus 3 over 10 plus 3 over 4. If you want to pause, have at it. If you don't want to pause, one last ride. So, again, I've got a bunch of fractions. Noticing 2, 5, 10, and 4, I should look for the least common denominator. The number that I can multiply all 4 of these fractions by to get rid of all of that division. Hopefully you figured it out. 2, 5, 10, and 4 all multiply to 20. So I'm going to multiply all of my fractions by 20. 1 minus k over 2. So I'll maybe use my, for the sake of it, why not? I'll just write it out. So I've got 20 times 1 minus k over 2 minus 20 times 2 over 5, which is greater than or equal to 20 times 2k minus 3 over 10 plus 20 times 3 over 4. So here, again, I can think of all of these as 20s over 1. Let's cross simplify. 20 over 1, 1 over k over 2, or 1 minus k over 2. 20 and 2, 2 goes into 20 10 times. 5 goes into 20 4 times. 10 goes into 20 twice. 4 goes into 20 5 times. Okay, and from here, all I've got to do is multiply. So now I have 10 times that 1 minus k, minus 4 times 2, which is 8, is greater than or equal to 2 times that 2k minus 3, plus 5 times 3 is 15. So here, I've got some parentheses. Let's distribute. If you did that distribution already, that's great. I wrote out the extra step. It can never hurt. 10 minus 10k minus 8 is greater than or equal to 2 times 2k is 4. 2 times negative 3 is negative 6 plus 15. Let's combine some like terms. On the left, 10 and negative 8. 10 minus 8 is 2. Carry down my negative 10k. Greater than or equal to, on the right, negative 6 plus 15. Well, that's 4k plus 9. Now, maybe I'll move everything to the left this time just so I get some practice with a particular type of operation. Minus 4k. Cancel out on the right side. I've got 2 minus 14k is greater than or equal to 9 minus 2 from both sides. I've got negative 14k is greater than or equal to 9 minus 2 is 7. Divide both sides by negative 14. Notice here I'm dividing by a negative, so I'm going to need to do a backflip. So I'm going to flip my sign, and then I'll say, well, on the left side, negative 14 divided by negative 14 just leaves me with k. Flip my greater than or equal to a less than or equal to, and 7 over negative 14 reduces to negative 1 over 2. In this case, it's been just so happened that I have a whole bunch of like graphs that happen to be less than or equal to. That's totally fine. So here, I need to plot negative 1/2. That's the most important number. Maybe I'll count by halves. Going up by 1/2, I get to 0. Going down by 1/2, I get to negative 1. Keep going. Keep going. Talking about values of k. Negative 1/2, in this case, it's less than or equal to. That gives me a shaded in circle. K needs to be less than negative 1/2. So I'm going to color in the left side of my number line. Finally, I just need my set builder and my interval, and I'm home free. Well, for set builder notation, I want the set of all values of k such that k is less than or equal to negative 1/2. Interval notation, on the left I start at negative infinity, go all the way off. On the right I end at negative 1/2. Negative infinity always gets a parentheses, it's never included. Negative 1/2 in this case has a closed circle. It gets a square bracket. Beautiful. Thank you for bearing with me as my voice slowly gives out. Have a wonderful rest of your day. Take care, be well. I'll see you when I see you, and good luck with homework 2.5. Goodbye.